So good evening everyone. So next part will be coming to the from third unit. So I am M. S. Shishwani working as an assistant professor at RMD Engineering College CSE department. So coming to the third unit is design and development of a business logic. So last class we completed the first half of the business logic organization pattern design domain module using the triple D aggregate pattern published domain event. Next now we are going to discussing about the kitchen service business logic, order service business logic, developing business logic with event sourcing, implementing an event store, using Saga and event source together. So first of all, publishing domain events. So to see the architecture here, the customer want to book any order means first of all he will going to place the order. Next one is an make a reservation. If seat will be reserved means the order will be confirmed. Then last next one is an making the payment. If payment is accepted means at last order will be confirmed. Here the project is divided into the some three modules. One is a customer aggregation pattern, order aggregate, and payment aggregate. So this is one of the sequence diagram. So comes under the UML diagrams. The basic UML diagrams will help the easy understanding of an project. Here the modules are the one is a client application layer, domain module, and then store. The client will going to generating a request means the order will be generated by the client. So whatever the request is generated, it is forwarding to the store, and then if it is order is an authenticated means the store will going to providing reply back to the application layer. Then application layer will going to place the order, and then the response will be providing to the client here. So first of all, we need to check out the models.py. So first I created one of the class is an order class, and then under the order class they created method is a diff initialization. Means def is acting as a keyword, int is acting as a method name, and passing variables are the self order ID, amount, customer ID. Inside the self ID, I'm going to replacing my values of the order ID, amount, and then customer ID. Then here repository file will be comes under the creating the class repository, and inside the class repository same I'm going to initializing with an self variable. So self is an one of the array. The so means whatever orders will be coming, everything will be storing into the self orders. One more method is an save. The save is will going to appending the each order. So each order will going to generating an ID, and then each order will going to generating the amount are also. And next one more file will be comes under the module is an event will be here. I'm going to using one of the package college and data classes package from importing the data classes. So data classes will going to maintain the class domain event, and then variables is a name and payload. Then coming to the class I created is an ordered placed, and generating passing the event is an domain event. Inside a class I created the initialization method, and the initialization I passing variables is an self order ID, amount, and customer ID. So inside that one I created one more method is an super method for the initialization. For order placement is an the duplicate values, redundancy values will go into the maintaining purpose. And next coming to the event bus, under the event bus also initializing within self variable. So whoever subscribers will be there, everyone is storing here. Then I'm going to defining the subscriber method passing variables or the self event name handler. If event name is not a self subscriber, then subscriber event name is acting as one of the array. Self subscriber event name I'm going to the appending, and then at last I'm going to publishing the events. Then here one more method is a service method, class order service, and then place order service, and last one is in publishing the domain events. So after then the client will going to get the reply is by using the handler package, send a mail, reduce the stock, and log order. Send a mail is nothing but an payload. So here I am going to paying the load, log order, payload. And one more is an see the kitchen service business logic is an taken as an example. So microservice architecture, a modern approach to the software development, offers the significant advantages for managing the complex workflow within a kitchen service business, such as a restaurant or a food delivery service. By breaking down the monolithic kitchen system into a smaller independent services, each managing a specific part of the kitchen workflow, business can achieve greater flexibility, scalability, and resilience. Then coming to the here. The states will be comes under the create pending, await acceptance, accepted, and preparing, ready for pickup and picked up, and cancel pending, cancellation, reservation pending will be there. Our next one is an order service business logic. Order service business logic in a kitchen service microservice architecture. So, the order service is a central component in a kitchen microservice architecture responsible for managing the entire life cycle of a customer food order for placement to delivery. It is a business logic encompasses a range of functionalities and interactions with other services to ensure a seamless and efficient ordering experience. So here we having the one is an order creation, validation, order processing, order status management, order modification, cancellation, order ticket tracking, and order history. And next, developing the business logic with event sourcing. Event sourcing is a different way of structuring the business logic and persisting the aggregates. It persists an aggregate as a sequence of events, and then each event represents the state change will be there. Then coming to the order services is a local transaction of an order aggregate, event sourcing, event tables, event ID, event type, event payload will going to the generating. So after event publishing through an event store, it is moving to the order topic, event broker, then billing microservice architecture and consumer microservice architecture. Some of the key benefits of the event sourcing are can reliably publish the events whenever the state of an aggregate changes. It can provide an audit logic that is granted to be accurate. It stores the entire history of the year, each aggregate allowing to require them to a later stage. Implementing an event store is comes under the place the order a service to the customer service. So both a order service and then customer service will going to maintaining the independent databases. We have two microservices as accepted. Each has its own code base supporting domain driven design. So using class aggregate, each has its own databases. Mobile app sending and HTTP post request to a REST API order services. Order services send an HTTP GET request to a customer service to check the customer has a sufficient credit. Upon sufficient credit, the order service send an HTTP post request the customer service to receive the credit returning reserved credit message. The customer service save the updated credit state to the customer's database. The order service saves the order in an order database. So here placing the order for an order service, publishing the order and then subscribing. The credit will be executed, created or failed after service bus or message broker. The subscriber to create an order event and publishing the event. Next coming to the here transaction log tailing, a log file transaction store of the database, retrieving a newly saved or updated item, creating an event, then publishing the event. Order services is an order document, transaction store, and store reader. And next coming to the getting back data. So far we have only considered microservices for write, but what about getting data back? Some code will need to perform an HTTP GET request to each and every microservice. The code will then need to store the each response in main memory, figure out the result, then produce a sensible result that can be easily rendered. This may offer very poor performance. The customer get the customer order payment deliver they merged together order service, customer service, delivery service, and payment services. And next coming to the here the one of the main architecture will be defined here how successfully the order will going to placing by using the order create event producer added the basket of the event and, product remove the from basket event. And next one is up to now we can discuss it about the how the order will be successfully placing how the for an app we how we successfully applying the microservice architecture when we compare to the monolithic architecture. The microservices architecture will going to playing the one of the major role for why because of the each and every time uploading purpose the microservices only help to fastest accessing of the data in any project compared to the traditional approach like a monolithic microservice will going to acting as the major role here. Thank you.